So we're going to look at the general solutions of trigonometric equations. So obviously related to the standard solutions, which was 3.3 in your book. And we've a video done on that as well, just looking at kind of generally solving a trig equation. But what we want to look at now is getting kind of the general solution, and then how can we use that general solution to find the kind of specific solutions within a given range or within a given domain. So we've looked at the graphs of our trig functions. So we have a cosine graph here. And what they're trying to kind of demonstrate here is that if we have a cosine graph and we're given a value such as y is equal to a half, we can find an infinite number of solutions to that equation. So it goes on forever in either direction. So even though on the page here we can only see a certain number of those solutions, so we can see kind of the 4 here within a certain range, if we were to continue, or the 5 there, if we were to continue on, we would be able to find other solutions to that equation. So that's the equation cos theta is equal to a half. So because we know this, we can use that information then in solving these equations. And if we think about this value here, say 60, when does that exact value repeat again? Well, it repeats at 420, which is an addition of 360. And if we remember, that's the period of a standard cosine graph. So we know that these graphs and these equations, those solutions will repeat themselves after we add the period on. So if the first instance is 60 degrees, the next instance is 360 degrees more than that, and so on and so forth. And this is what we call the general solution of the equation. Okay, so you can see the example here. Theta is equal to 60 degrees plus n 360, where n is an integer. And what we do is we let n be equal to 0 if we're looking at the first cycle, and n then indicates how many periods do I want to add on. So if n is 1, I'm adding on 1 period. If n is 2, I'm adding on 2, and I'm seeing where it's repeating and where it's coming up again, essentially. So as a more general rule, I suppose, if we have sine x or cosine x or tan x, then our general solution for each of these is x plus n 2 pi. Okay, where x is the value here. Okay, where x is the value here and x is the value here. Okay, so following that same idea, so if we have cos theta, then our general solution is theta plus n 360. And if I had, for example, sine 2 theta, then my general solution is 2 theta plus n 360. Okay, so taking, again, that same value, so the value that's there for x, if you like, and just following that through as best we can. So what we're going to focus on is the solutions for sine and cosine, and there's a few things to be aware of. The first thing I'd say is looking at the question and seeing whether it's in radians or degrees, because that's going to be really important to how you give your answer, and we saw that kind of just generally in solving the equations. The steps we follow are, first of all, find the two solutions as normal. Okay, so that's coming from your trig equations. Okay, so the kind of standard trig equations. So that would find our solutions from, if you like, 0 to 360, any of the solutions within that range. So there should be two solutions within that range if that's the period of the graph. Then we add on n 360 or n 2 pi to each solution. Okay, so depending on whether it's in radians or in degrees. So we can make a note of that as to why. So depending on radians or degrees. So it depends on the question, depends what we're given in the question. Then to find for a specific domain, we let n equal to 0, n equal to 1 until we're outside of the domain. So we take these values, we follow them through, and we see until we've got outside the domain that we're allowed in. So let's just try and apply it to a question, because obviously if we, when we work through it, it works itself out a bit clearer. So sine theta is equal to a half. So our first step is to solve as normal. So we look at the question, we see that the answer is positive. We know for sine that sine is positive in two quadrants. It's the first quadrant and the second quadrant. Okay, so those are where our two solutions are going to lie. What we need to do is find our reference angle. So sine of my reference angle is equal to, and we say the positive value, so a half. Then my reference angle is going to be sine inverse of a half. So I take my sine inverse of 1/2 and I get an answer of, let me see, I'm going to do it in degrees, just so we can keep with it, I suppose. So my reference angle works out to be 30 degrees. So filling that in to my little diagram, so I have 30 degrees here, 30 degrees here, I'm finding my two solutions. So my first solution is 30 degrees. My second solution is this blue line the whole way around, and that's going to be 180 minus 30, which is 150 degrees. So my two solutions for theta are that theta is either 30 degrees or theta is 150 degrees, because both of those values will solve this equation. Okay, both of them give me a positive answer for sine, so they're both going to give me the same value, that value of a half. So sine 30, sine 150, both the same answer. So that's my first step. My second step then is to write this in the general form. So we're looking for the general solutions. So for sine theta, my general form is going to be theta plus n 360. Okay, so the 360, obviously coming from the fact that we're using degrees. So we're using degrees. The theta coming from this part here. So it's theta in the question, so our general solution is theta plus n 360. So my two solutions are 30 plus n 360 and 150 plus n 360. Okay, and those are my two general solutions. Okay, those are my two general solutions. So my answer is either 30 plus n 360 and 150 plus n 360. Those are my general solutions. And we're not asked for this question to actually work out the value of those for any specific number of cycles or domain or anything like that. So that's just our answer, and we can stop there. So highlight our answer. Let's apply this now to another question. So find the general solutions and then find all solutions in a specific domain. So let's focus on the general solutions first. We look at our answer, it's going to be negative. So our first step is just to solve as normal. We can draw a little sketch. We're looking at cosine, and cosine is negative in the second and the third quadrants. I want to get my reference angle. So my reference angle is, we take the positive value, so root 3 over 2 instead of the minus, and I get that OR is equal to cos inverse of root 3 over 2, which gives me, again, 30 degrees. We're kind of doing the same kind of thing here. So finding my two possible answers, this one is going to be 150, as we had before, and the blue option here is going to be 180 plus 30, which is 210 degrees. So my two solutions are that theta is equal to 150 degrees and theta is equal to 210 degrees. Next, to find the general solution, we're going to add on that, we're asked to find theta in radians. So let's go through that again. Okay, same idea, but we'll just give it another go. So we need to go back to finding the cos inverse, so making sure my calculator is in radians, and this is why it's important to read the question. So pi in radians gives me a value of pi over 6. Okay, so my reference angle here, at these points here, is going to be pi over 6. Okay, at these two values. So my red value here is going to be 180 minus pi over 6, or pi minus pi over 6, which gives me 5 pi over 6. And the blue answer here is pi plus pi over 6, which gives me 7 pi over 6. So my two solutions are that theta is 5 pi over 6 and theta is 7 pi over 6. Okay, so benefits of reading the question, making sure that you're happy. So let's have a look, and we need to change. I'm going to change my little question first here. We're going to say from 4 pi. Okay. So following this through, then to find our general solution, we're going to do theta plus 2 pi, so n2 pi, which is going to give me an answer of 5 pi over 6 plus n2 pi and 7 pi over 6 plus n2 pi. Okay, so 5 pi over 6 plus n2 pi, and 7 pi over 6 plus n2 pi. Now, as part of the third part, we're given a specific domain that we have to find our answers in. So our answers for theta are going to be between 0 and 4 pi. Okay, so it's between 0 and 4 pi. So let's have a look. So if we say n is equal to 0, I get my 5 pi over 6 and my 7 pi over 6. If I say that n is equal to 1, I'm going to get 5 pi over 6 plus 2 pi, which gives me an answer of, so 2 plus 5 over 6 gives me 17 pi over 6. And if I do 7 pi over 6 plus 2 pi, I get an answer of 19 pi over 6. If we say then n is equal to 2, again just testing out our options here, 5 pi over 6 plus 2 by 2 pi is obviously 5 pi over 6 plus 4 pi, which gives me an answer of 29 pi over 6. And what we should kind of notice or think about at this point is 29 pi over 6 going to be bigger than 4 pi? So let's take a pause just to have a think. Well, by checking the fraction, we can see that it actually is bigger than 4 pi. It's about 4.83 pi. Okay, so it's about 4.83 pi. And what that means for our question is it's outside the domain. Because if you remember from our domain, from our question, we had been told at the start that our answers had to be in the domain 0 is to 4 pi. That means our answers have to be between 0 and 4 pi. And this answer here is bigger than 4 pi. So our four solutions are going to be, so our four solutions for theta are 5 pi over 6, 7 pi over 6, 17 pi over 6, and 19 pi over 6. And this is how we would end our questions, by just writing out that set of solutions really clearly so that we can clearly see kind of what the solutions are, particularly because we maybe need to go that extra step to kind of check whether solutions are allowed or going to fall within our range or within our domain, things like that. It's important to just go that extra step. So let's do a few more of these questions just so we can see, so we can get familiar, so we can give you more maybe just to kind of watch and to kind of try for yourself and then see, are you able to follow the solutions well. So looking at the next question, sine 3 theta is equal to a half. So we solve it the same way as before. So looking at the question first, I know that the answer is positive, so I'm in these first two quadrants. I know that sine of my reference angle is equal to a half, which means that my reference angle is going to be, and I think we've done this one already, but we'll do it again, pi over 6. So looking at my reference angle, so I have my two values here of pi over 6. My first value is just pi over 6. My second value, again, we've kind of already seen this one, gives me 5 pi over 6. So that's from pi minus pi over 6. So my two answers, and we have to be careful at this point because the question was 3 theta. The question was 3 theta. So my two solutions are that 3 theta is pi over 6 and 3 theta is 5 pi over 6. Okay, so what we want to see now is our general solution. So if we remember from the start, our general solution for 3 theta is 3 theta plus n2 pi. Okay, 3 theta plus n2 pi. So for these two options that I have, it's pi over 6 plus n2 pi, and it's 5 pi over 6 plus n2 pi. Now, I would like to solve not for 3 theta, but for just theta. So in order to get just theta, I'm going to have to divide by 3, which is going to give me pi over 18 plus n2 pi over 3, and 5 pi over 18 plus n2 pi over 3. Okay, and that's our general solution then for this equation. So you can see the difference between this one And the last one is that last step here. So let's go back over that really quickly. Why did I have to divide by 3? Well, looking at the question again, the question I was solving for was 3 theta. We have already seen for a question like that, that the solutions I end up with, so my pi over 6 and my 5 pi over 6, are solutions for 3 theta. So the solutions for theta are 3 times less than that. The best way to give my general solution, if we remember from before, the reason we have 3 theta here is because the 3 theta is what was in the question. Okay, this is how we've set it up. This is how we set it up in the previous one. We kind of made a point of highlighting it green there. So our 3 theta is equal to 3 theta plus n2 pi. And then if we divide by 3, that gives me the answers for theta, which is pi over 18 plus n2 pi over 3, and so on and so forth. Let's apply this then to another one of the questions. So we're looking to do a sample exam question. So find all the values of x for which cos 2x is equal to minus root 3 over 2. So let's have a look. We're finding all the values within a particular range. So our range of values is within 0 is to 360. So let's have a look at the question. So first of all, my answer is negative. So I'm going to be in the quadrants where cosine is negative, which is the second and third. Then we need to take our question, we need to look for our reference angle. Again, we take the positive value, so the root 3 over 2. And I find that my reference angle, we're working in degrees this time, so back to degrees again on your calculator if you're following along. And cos inverse of root 3 over 2 gives me a value of 30 degrees. Yeah, I feel like every single question we've done has been 30 degrees. But that's okay. We're focusing on method. Okay, not numbers, method. So let's see, so that's 150 degrees, and following through, this is 210. Okay, we're nearly familiar with these numbers now. Okay, we have to be careful, same as the last time. Our question is for 2x, so our solutions, our general solution is going to be 2x plus n 360. Okay, 360 because we're in degrees. So my two solutions are, for 2x, 150 plus n360 and 210 plus n360. Okay. To find the value of just x, what I need to do is divide across by 2. And that's going to give me a value of 75 plus n180 and 105 plus n180. Now, in order to get the actual solutions, I need to take different values of n. So let's start with n is equal to 0. That gives me 75 and 105. If I look then when n is equal to 1, that's going to give me 75 plus 180, so 255, and 105 plus 180, which gives me 285. Then we can try maybe where n is equal to 2. So when n is equal to 2, I get 75 plus 360, which gives me 435, and that value is outside my domain. Once we hit a value that is outside the domain, we are free to stop. Okay, once we hit a value that's outside the domain that we have, then we can stop. Remembering that our domain in the question was 360. So I've now hit a value that's outside 360 degrees, so I can't have any more answers. So that means that my solutions for x are 75, 105, 255, and 285. So remember, we're looking for all the possible angles within that given range of 0 to 360 that would satisfy this equation. And why do we have more? Well, we can think about what it means. We have cos 2x, and we should remember from our functions that that means that the period for this function is actually just pi. So it's repeated twice within a range of 360. And that's why we end up with double the amount of values. Let's finally just look at the last one. So we have 3 tan x is equal to root 3 over, or sorry, not root 3 over 3, root 3. What we can do with this one, the first step we could do is divide by 3 to get root 3 over 3. Now, again, we're looking for tan, and we know that tan is positive in the first quadrant and the third quadrant. Okay, so we can find a reference angle. So tan of my reference angle is root 3 over 3. My reference angle is the tan inverse then of my root 3 over 3, which gives me 30. And then if we include this then in our little diagram, so 30 degrees here, 30 degrees here. So this angle is 30, this angle is 210. So my two answers for x are 30 and 210. Now if we find our general solution, well, what we should see here, so we can find the general solution, which is x plus n360, but what we should see is that in actual fact, we can't have any more options because my domain was only 0 to 360. So for this function, the only values that will end up within 0 to 360 are the two that I had, 30 degrees and 210 degrees, because any more would be outside my range. So the key things to note here, I suppose, is that little step on from the previous ones. So being comfortable with the idea of the general solution, making sure that you know that the x there is whatever's in the question. That's how we set up our general solution. So we're always adding on the period, but we're setting it up each time, and we may have to divide at some point, like we did in this one with the dividing by 3, or in the next one where we did the same, we divided by 2. When we set up the general solution, we use the answers we've come to in the question, and we add on the period, and then we divide across by 2 in order to solve it. And it just makes sure that we're keeping everything consistent then as we're working through the questions. The only other differences then are just having that consciousness, I suppose, that you have those extra questions, those extra solutions to look for really. Everything else then is fairly straightforward, or follows on, I suppose, not straightforward, but kind of follows on from the other trig equations that we've already looked at.